Welcome to the Explainer. Today, we're diving straight into Python integers and turning basic math into an absolute programming superpower. If you've ever wondered why your math behaves just a little bit differently in Python compared to a standard calculator, well, you're in the right place. Let's get right into it. Here's our roadmap for today. We'll hit Python's 7 arithmetic operators, master its 3 divisions, uncover the underrated modulo, look at some pro tips for clean code, and finish up with a quick flashcard recap.
All right, Section 1, Python's 7 arithmetic operators.
You know, what's really wild is the fundamental nature of how Python handles whole numbers. In other programming languages like C or Java, numbers have this rigid size cap. They can literally just overflow if they get too big. But Python integers, they don't have that problem. They are immutable, sure, meaning they can't be changed once created, but they'll just keep growing and growing as long as your machine has physical memory to spare. It's incredibly freeing, especially when you're dealing with massive data sets, complex hashes, or heavy scientific calculations. You just let Python do the heavy lifting.
So, you actually have a massive toolkit at your disposal. This is your ultimate cheat sheet for the 7 standard operators. At the top, you've got your familiar friends, right? Addition, subtraction, multiplication. They work exactly like they did in elementary school, perfect for basics, scaling, sums, and differences. But then, we get to the operators that give Python its distinct flavor. True division with a single slash, floor division with a double slash, modulo with the percent sign, and exponentiation with the double asterisk. You're going to want to keep your eyes on those last 4, because mastering their specific quirks is what separates a beginner from a truly proficient Python developer.
Moving right along to Section 2, mastering Python's 3 divisions. Okay, a huge anti-pattern I see with beginners is using true division, that's the single slash, when they actually just need a whole number. Here's the thing, that single slash always gives you a decimal float. Even if the math is perfect, like 8 divided by 4, Python spits out 2.0, not just a clean 2. And why does that matter? Well, you can't exactly look up the item at index 1.75 in a list, right? If you need a clean, unbroken integer representing whole units, you absolutely have to use the double slash for floor division. But wait, there is a classic beginner trap here. Floor division doesn't just lazily chop off the decimal point. Mathematically, it always rounds down toward negative infinity. Let that sink in for a second. Positive 7 floor divided by 4 rounds down to 1. But negative 7 floor divided by 4, it drops further down the number line into the negatives. It lands all the way at negative 2. It does not round backward towards 0 to become negative 1. Getting a firm grip on this specific quirk is going to save you hours of frustrating debugging. Let's ground this with a practical example. Say you're writing an app for a warehouse. You've got 27 items, and each shipping box perfectly holds 4 items. By using 27/4, boom, you instantly know you have exactly 6 full boxes. It is literally the most efficient tool for grouping things, calculating website pagination, or figuring out how many full weeks are in a certain number of days. Let's shift gears to Section 3, modulo the underrated operator. So we just saw how floor division brilliantly tells you how many complete groups fit into your total. But that naturally begs the question, how do we elegantly figure out exactly what's left over? Like how many items are just sitting there on the warehouse floor because they didn't make it into that final box? Enter the modulo operator. It's the percent sign, and it works absolute real-world magic. Yes, it grabs your leftovers. 27 modulo 4 leaves us with 3 unboxed items, but it's so much more than that. You can effortlessly check for even numbers just by seeing if your variable modulo 2 perfectly equals 0. If it equals 1, it's odd. And my absolute favorite trick? Cycling structures. By calculating your current index, modulo 7, you can endlessly loop through the days of the week without ever throwing a terrifying out-of-range error. It just automatically resets your sequence. Section 4, clean code and pro tips. Okay, readability is everything. Trying to read a massive string of zeros? Total headache, and honestly, a prime spot for a typo. Python gives us this amazing trick, though. You can use underscores to visually separate digits in large numbers, basically just like you'd use commas on paper. Writing 8_100_000, Python's interpreter completely ignores the underscores. It still perfectly evaluates to 8,100,000,000, but your code becomes infinitely more readable without changing the integer's underlying value. It's a real game changer. Here's another brilliant pro tip. What if you need both the complete groups and the leftovers at the exact same time? Please skip doing 2 separate math operations. Stop typing out floor division and modulo on 2 separate lines. Just use the built-in divmod function. You hand it your 27 items, your box size of 4, and in one beautifully clean step, it hands you back a 6 and a 3. It's just an elegant, highly Pythonic way to write faster, cleaner script. All right, let's lock all this knowledge in. Section 5, quick flashcard recap.
Quick question. You jump into your terminal and type 7/4. What does Python spit out? It's 1.75. Because remember our golden rule, true division with a single slash always returns a precise float.
Okay, what happens if we switch that up and use the double slash floor division instead?
It returns exactly 1. It acts as an integer, grabbing the whole units and mathematically rounding down.
Next one, you're building an app and you need a quick logic check to see if a variable is perfectly even. What's the code?
You use n modulo 2 equals 0. 0 leftovers means it's an even number. This is the absolute standard way to check for evenness across Python. Final pop quiz before we wrap up. What does 2 double asterisk 8 evaluate to? Think back to our cheat sheet.
It's 256, because those double asterisks are your secret weapon for exponentiation. It simply means 2 to the power of 8.
Which brings us to the end of today's explainer. Take a hard look at the codebase you're working on today. Are you unintentionally forcing floats with a single slash when you really just need integer floor division? Are your coworkers squinting at your code because you're not using underscores for those massive numbers? Small optimizations and how you handle basic math, especially using modulo and divmod, can dramatically elevate the readability and performance of your code. So the question is, are you ready to rewrite your math and unleash the true power of Python? Get out there and keep exploring.